Hello, everyone. Uh, Share screen. And is anybody presenting today? No? Yes? No? Okay. So let's just quickly look at the schedule. And by the way, so next Tuesday, we're not going to have class because um, it's following a Monday schedule, right? So next time we'll meet, will be Thursday, a week from today. Okay. Okay. So let's look at the schedule. Um, I have the schedule here. Um, but by the way, if I forgot to give somebody a grade for a presentation, I think I might have. Just send me an email to remind me. Um, I think I forgot to give somebody a grade. So anyhow, let's look at the schedule. And so here we are. Um, and we have the schedule. And it's according to this at least, uh, we have, okay, so today so we're uh, uh, the ninth, and then so we have two more classes, and then we're going to start the review for the midterm. So we're pretty much on schedule, okay? And then after the midterm, we'll start working on the project, okay? So so today, I just want to finish up object-oriented programming, and then I wanted to work on chapter 3, and if we could do that, that'd be great. So, and then maybe we could throw in one design pattern if we have time next week. Yeah, next week. Okay, um, so where are we up to? Okay, here. Uh, okay, so just want to finish this up. We actually did everything in this list. Um, and the only thing I think we left out, we did the dependency inversion principle, which we said basically means to to uh, to always, in other words, it's like it's easy. The way I think of it is like if you manufacture a car, right? So you want to use, let's say, a wheel size, which is commonly used, because otherwise the people who buy your car or you yourself are going to have to pay more money to get a tire, right? Or it'll be hard for other people to replace the tire, right? So you want to get something. So the more standard the parts of the car are, the more easy it is to fix, right? So, or you don't, or the less work is involved, right? If you have a standard tire, there's a lot less work involved to get a new tire, right? So the same idea with code is that the more general it is, then it's easier to change parts of the code without having to, you can just swap parts of the code without having to change the parts that rely on it. Okay, that's why it's called dependency inversion principle, is that we want to take away that dependency. We want to remove as much dependency as possible because the more specific the connection between two objects, then when we change one object, we're going to have to change the other object also. So the least specific, the more general is always better because then it's much easier to you can make a change without having to change in one spot without affecting all the other places, right? Like you could change a tire without having to get a new rim and all that, right? You could just things are easier to swap in and out. Okay. Um, okay. So actually, I'm not going to do delegation principle because yeah, I'll do it. Why not? Okay. Okay. So I think we did everything else. This is dependency version. We did dry, which was don't repeat yourself, right? Because we said that when you should have all the logic in one location, right? Because if you're going to repeat the logic in different places, then when you update that logic, you're going to end up forgetting, you'll change it, let's say, in two places, but not in the third place. And then later on, that's going to come to bite you, right? You're going to, uh-oh, I forgot to change it over there. So the idea of don't repeat yourself is always put the same logic in one location. So it actually, the code runs slower when you do that, right? But because every time, because often when you do it like that, you'll have a method call which actually is slower, right? There, because a method call has like certain overhead in the processor. But even though it's slower, but nowadays we don't worry about speed. We usually, the only thing we worry about is, it's what's expensive nowadays. It is what's more expensive, buying a better computer or paying a salary, of let's say 100,000, 150,000 for a good software engineer, right? It's a lot cheaper to just buy a better computer, right? So we don't worry about speed, right? We worry more about a bug because a bug takes time and that's very expensive, right? So nowadays it used to be the other way around. It used to be the computers were expensive compared to $1 million computer, right? Which, filled up a whole big room with a special air conditioning unit and all that, and special people would sit there all day operating it, right? So the computer was expensive and the people were cheaper compared to the computer. But nowadays it's the other way around. It's that the people are expensive and the computers are cheap. So it used to be like a big deal to save a microsecond or on when you wrote code. But nowadays it's just opposite that we don't care so much about speed. Of course, it's always good to have well-written code, but if it, but we don't care. It's not that much of an issue, right? It's not, it rarely is an issue, right? Unless you're working for Google and or you're doing stock market trades. So then speed is not really an issue. You just get faster process, just spend a little more money on hardware. Um, or memory or something, right, to make it faster. So, okay, then we have the Yagni. The Yagni stands for you aren't going to need it. So it's very interesting that, as most people think, if they write a piece of code and it ends up not being used, so most people think, well, I spent, a whole day writing this or a week or maybe even a month writing this beautiful object and does all these things, even though we're not using it now, but we might use it. Or somebody will say, my boss asked me to do, let's say, printing, but maybe I'll just throw in also, let's say my boss asked me to print to Excel to export the data to Excel, but maybe I'll also, while I'm writing this method, I'll write another one that exports to a PDF, right? I'll throw it in, right? So the idea of Yagni is never, it's always well, not always, but in general, it's a waste of time to write code or to keep code that doesn't do anything. I'm sorry, not that doing anything, that's not being used. Let's say, for example, imagine you have a house and every time instead of throwing things in the garbage, you just put everything in your attic or in your basement. And slowly your garage, your attic, it builds up with all this junk or clutter, let's say. Let's say to you it's not junk because it might be useful. You might need a sewing machine or a typewriter or whatever, or it might be worth something. So to you, you're saying, well, why not just put it there, right? Why not leave it around? Well, the answer is because eventually all that clutter is basically there's a cost to it, right? Like it takes up space, right? And let's say you need to store something, you're going to have to waste time to go through all that clutter to find what you're looking for. So there's a cost associated to keeping unnecessary things around. And especially with code, that's true because with code, there's two ways that keeping unused code is a waste of time. Number one, if the code that's not being used is part of the code base, what happens when you change something in the code? The code has to compile, right? Well, if the code has to compile, that means you have to maintain unused code, which is a waste of money, right? So one reason not to have unused code is because you're wasting time to maintain it, right? And another reason is because let's say someone doesn't know that this code isn't, this happens to me a lot where I work, by the way. Well, I've tried to get rid of it a lot, but like sometimes you're looking for all places where a certain method is being used and you find it's being used in 5 places, right? So because you want to know, like changing this method, what is it going to do to the code, right? It's a common problem, right? You want to change something in the code and you say, well, what's going to be messed up? What could get messed up when I change my code? So you do a search in your code and you find it's used in 5 places. And then after a while, you realize, wait a second, one of those places that I was worried about, that code isn't being used anymore, right? But I was when I was looking for where that method is being used, it was one of those places, but that method is never, but the place where I found it and that I was concerned about isn't being used anymore, right? So I was wasting my time when I was trying to fix code, I didn't realize that there was code there that wasn't being used anymore and was just left in. No one deleted it or removed it. So it's always a good idea to delete unused code for those two reasons. Okay. So number one, because it's because there's a cost of maintenance, right? So unless you need it, get rid of it. So you don't have to maintain unused code. And number two is there's a confusion it creates because usually you have a team of people working on the code and they don't realize that this isn't being used anymore and it just you just let somebody just left it lying around and they're worried about, well, am I going to break it, and it's never even being called, right? So it could be that nowadays modern compilers or AI, IDEs and all that stuff, they might figure that out, that the code is never being used. Um, so, but, 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 for- but basically that's the idea of Yagni. Okay. So what did I write? Maintaining is good. Yeah. Um, uh, okay. So I didn't, uh, write the other reason, which is, um, I only wrote um, the first reason, and the second reason is because it's confusing. So I'll just do A and B. So A is what we just said, it's expensive, and B is it's confusing when looking at the code to understand which um, to understand uh, which code is actually being used. Okay, so we don't want to waste our time doing that. And the last thing is you find this in a lot of systems where actually let me leave out the principle and just explain what's not good with this code. So actually okay, let's just well, okay, let's explain. So basically sometimes you have let's say you have some code where originally it was going to be a red duck, right? The code was to draw a red duck. And then someone said, you know what? We need it sometimes to be blue, sometimes to be red. So, being the lazy person that I am, so I'm going to say, you know what? It's really the same code, just it's red or blue. So the only difference is the code. So I say, I'm going to add an if statement and I'm going to pass in red or blue. And if it's red, then it's going to, a red duck, then I'm going to draw a red duck. And if I pass in a blue duck, then I'm going to draw a blue duck. And if I don't pass in anything, I'll just do a plain generic duck. So the problem with this type of code is that it's basically we're putting all the logic in a bunch of if statements, and we're being lazy and we're making like complicated code where what we should really do is in this case is we should really have separate objects or separate behaviors um, between the red and the blue and the generic duck. So when you have a lot of if statements, when you see a lot of if statements, you know something is wrong, right? That your code is going to end up being very um, it's going to have to be changed a lot because what happens when you add a green duck, then you're going to have to add another line. And then what happens if you want a red and blue duck, then you're going to have an or statement. And eventually this code is going to be a mishmash. So whenever you see code like this, which I do see because people are like lazy, say, well, it's only a one change, So it's only one, it's only a color, and then eventually it's not just a color, it's how it behaves, and then it grows into something else, and then, slowly things get added on. But this if statement just gets more and more complicated, and this whole code becomes a nightmare after a while. So whenever you see this type of code, you realize that it's better to have different objects. I really wrote child class. It's not really a child class necessarily, but it could just be a different class, right? Meaning that we should delegate the red or the blue drawing to a separate object, which is like passed in, right? That would be using composition or using inheritance. That would also be we can inherit from a duck and give a red, blue, and green duck inheriting from duck. But those ways are all better than having this if statement because this is just going to end up being a nightmare to work with, right? The best way would be composition, where you would have the drawing behavior of red, blue, or green passed into this object, right? That would be the best way, right? We would pass in a the red, the how a red duck gets drawn. We would how that's different than the blue and the green. We would just pass that in as separate objects, right? We'd have a green drawing object, or like a green crayon we would pass in, or a blue crayon or something like that, right? We'd pass in, let's say, a crayon object or a shape object or something like that, or a background object, right? That would be the better way to do it than have a bunch of if statements. Okay, so that's it for the object-oriented principles. And then I want to any questions? Okay, so I want to next move on to um, chapter 3. Okay, so we're getting close to the midterm material. By the way, the way it works with when I do the review for the midterm is I usually, because there's usually not enough time to review it. So usually what I do is, I mean, we don't have enough time to review everything that's going to be on the midterm. So usually what I do is I usually do, let's see, when is the midterm? It's usually like the Sunday before the midterm. I usually, like, it's voluntary, if you want to, like, I do like Sunday evening. I usually do it online. So if you want to, extra review, I'll do it then. Okay? So that's usually how I do the review. So when is the midterm again? It's no, what day of the week is it? Oh, Thursday. Oh, oh, so how would we do that? Maybe I'll make it Tuesday so we could have it. Is it okay? You think it's okay if I move it to the next Tuesday after that? I'll send an email out, but I think I'll move it to a Tuesday, then we can have a Sunday for extra time for review. Okay? Makes sense? And then I could do Sunday from like 7 till whenever we're done. Yeah, yes, you have a question? Yeah. Yeah. I mean, basically, if you just go through the folders, all the files there, that's gonna, so that's really the review sheet. But we'll go through it also. Okay. I mean, that's really all I'm going to give you is, but if you just go through the folders, okay, you have access to the folders, right? Yeah, so just go through, look at all the documents, see if they make sense. So again, I'm gonna try to make it Tuesday. If I'll send an email, if it's not a problem, then I'll change it, okay? And then we'll have a Sunday, like 7. Is that good? Is Sunday morning better, evening? I don't, it's all the same to me. So. I'll send an email, okay? I'll see what people comment. Yeah, whatever gets the least complaints. Okay, chapter 3. So chapter 3 in the book. So chapter 3 deals with agile. Before we do that, I just wanted to um, um, yeah, okay, I want to give a little introduction that this book has a lot of different terminology and it gets very confusing. So for our purposes, incremental, agile, extreme, scrum, it's all the same. Okay, so whenever you hear one of those words, you could just substitute any of the other words. Okay, so you don't have to worry whether it's incremental, agile, it's historical. No, originally I think incremental, then agile was like the year 2000 or 2001, and then there was extreme. And in the book they present it as a historical in chapter 3. But for our purposes, we don't care about the historical. We're just doing it, from the year 2025, and we just treat it all the same. Okay. So we're not, it doesn't make a difference to us, but the history is. Okay. Um, the I think I mentioned this before as an introduction to chapter 3, which is that it used to be that most companies, again, this is based on Uncle Bob, but I remember working on these type of projects, so I sort of remember that. So before the year 2000, well, I guess I was after year 2000, but the way that companies used to develop products was waterfall, meaning that they would, everybody would sit down, they would plan it all out, and then they wouldn't start coding till the very end. And then the problem was that they had run out of time, right? Because they allotted a certain amount of time for design, for requirements, for design of the code, the different parts, and let's say everything was perfect. And then when they got to the actual code, they ran into problems, right? We see it all the time nowadays, right? When you look at the Pentagon and there's a new type of plane or whatever, it's 99.9% of the time over budget and late, right? So like some things are like 11 years late or something, crazy because anytime you do something new, you could plan all you want, but when you actually have to do it, then you find all the actual problems that are going to crop up. So so a lot of projects failed for that reason. If they failed, either they were late or they were or just like I worked for 5 years at a company, and I worked on one project, and we were like 20 people, and they threw everything got well, after I left the company, I heard that they, they just they just disbanded everybody. I don't know if they got fired or they were assigned different projects, but the whole millions of dollars just thrown out the door or out the window because it just, it was because it was waterfall basically. They had all these plans. I remember they had this and this and this. Everything was like, this has to work this way. But then when it get down to the actually working, the actual code itself, they were just kept falling behind. And eventually the company said, forget the whole project. So this was common, right? It was very common with code. So the idea of incremental is to solve this problem of projects failing because of the time running out of time. Okay, so that's the basic issue, right? You're running out of time or money or both, right? So the way incremental solves this problem, does this sound familiar what I'm saying now? Remember we said this before, that the way incremental solves the failure problem of a project is by doing a little bit at a time, so we could guesstimate how much is actually going to get done, right? Because we do a little bit of planning, a little bit, I mean, a little bit of requirements, a little bit of design, a little bit coding, and then we start over again and over again and over again. So we keep adding another layer, another layer. And by doing it in this fashion, what happens is that we could slowly see how long what we can actually accomplish during the allotted time or the allotted money that was allocated to this project, right? We don't have to hope for the best, right? We could actually see how long things take, right? Because we're actually doing it in small steps. So that's the idea of incremental, okay? Um, I mean, there are other ideas that have since come about, but this is the main idea, right? The main idea of incremental is that we should be in, it gives the manager control of sort of like some sort of control of the project, right? It's instead of it's just like we don't know what's going to happen. We hope for the best, but instead we know how long things are going to take, and we could estimate accurately what will get done and what won't get done ahead of time. Okay, so that's very powerful because it makes a difference whether a project will fail or succeed, right? Because let's say we know we can't do everything, but we know it 2 years ahead of time. So then we could scale back, we could throw out those features that we don't really need, right? Or we could just scrap the project and say, okay, we're never going to be able to do it, so let's just scrap it. But we're not going to waste a bunch of years doing something and then finding out at the very end it won't work, right? Either we'll find it right away, we can't do it, or probably we'll just start throwing out things that are not that important and working on the important things and that way we'll finish whatever we can on time. Okay. So again, this is not going to work you can't do this for, let's say, sometimes you can't throw out things, right? Everything is important, right? If you're building an airplane, you could throw out maybe, the fancy seats or something like that, but you can't throw out, let's say, well, we won't do the wing. Yeah, you got to do, so it's not always possible to throw things out, but usually it is, right? Usually, like if you look at Microsoft Word, right, they keep on coming out with new features, right? Now they add AI to it. I don't know I don't know what they did. They'll write they'll do AI, whatever that is, for Microsoft Word, and uh, but they keep adding things. So, but you don't need AI to do Word. Microsoft Word is just a nice thing to have, right? You don't need. Most people probably only use, let's say, 10% of all the features that are in Microsoft Word. So you could get by with probably just 10% of most people, probably 80% or 80 or 90% of people using Microsoft Word just use maybe 10% of its features, right? Um, or even know how to use them. Okay. Okay. So number one is what I just said before. Um, okay. And a corollary to number one is which we said was, you see the word here, predict. We want to predict how long development will take. The corollary to that is that we can only predict if the code is clean, meaning that if some, in other words, if every time, every increment, meaning we do a little bit at a time, we can only accurately predict how long something's going to take if the code is stable, meaning in other words, it's not harder to code after 3 increments or 10 increments. The code doesn't get like very uh, buggy or very messed up, right? Because if the code gets messy after a while, then we lose our ability to predict, right? Because remember, the whole idea of agile or incremental is to be able to predict. So we can only predict how our progress is if everything stays the same, meaning that the code is clean every time we do an increment, right? Because otherwise it's comparing apples to oranges because you start out, there's no code, so of course you go fast, and then after 5 months you realize, oh no, this code is really full of bugs. Then all of a sudden you're gonna come to your production's gonna go way down, right? So in order to be consistent, you need clean codes. That's number two. Two is a corollary to number one, right? So, and three, um, and three is this is something about Scrum um, that specifically, I'm not sure if it's part of Agile, but it's is that when is the code done? So in those in Waterfall, when is the code finished? Well, you know, when you start out, you had a whole list of requirements, and when all those requirements are done, then you're done, right? But with incremental, remember we said that you could throw things at as you're going. If you realize you don't have time to do everything, you could throw out things, right? So incremental, when is the project done? It's when we say it's done, right? Because built into incremental is the idea that after each increment, the project could potentially be finished. Okay, that's a very powerful idea, meaning that if you're doing a waterfall project, it's like, someone's in the middle of doing a heart operation, they can't all of a sudden say, okay, we're out of time. Let's just, shut down the operating, you know, let's just leave, leave the patient on the operating table. We're done. Yeah, we ran out of time, right? You can't do that, right? But with incremental, the idea is that after every increment, we could walk out and say, this is our finished product. Okay, so basically, that is a very powerful idea because that means that at any moment, right, we're not stuck to having to do. Well, first of all, it's very powerful for two reasons. Number one, every time we go through it, it's complete, meaning it works. Whatever code we have works and it's been tested. And number two is that if we run out of money, all of a sudden still have a product, right? It might not do everything, but it'll do something, right? So, and also we were not forced into to doing a specific a bunch of things like in waterfall where it's not done until you do everything that you plan to do. Okay, so that's a big difference between the two. Okay, so this is just for, actually someone presented this, this is the Agile Manifesto, which basically um, states this is like the beginning of the like Scrum idea. One is that we value individuals and interactions over processes and tools, which means that we're not worried about. Basically, the idea is we want to get something working as opposed to um, being like very corporate and formal, right? We don't want to, uh, because we're formal, we don't want to give up the spontaneity that a group of people working together has, right? We want to utilize all the people in the team to produce the best software instead of worrying about who's going to get credit for it, who approved of this, right? Who didn't approve of it, who's paying for this, right? We want to just get a nice product working, right? We want to use that team effort not to have politics and fights about, who approved it, who didn't approve it. Is this what they want? Um, like today, someone sent me an email and I said, the code is working fine. I said, what's the problem? So the person replied to me, well, then you go to the manager, get approval and let them know that, this is how it's working. And then I'm thinking, wait a second, if you like it, it works. We'll have to go to the manager to get approval for something that you think is a good, like stuff like that is, it's nonsense. It doesn't add to productivity. If something is working and it makes sense and you like it, so why are you telling me to go ask someone else to approve of it? You have the power to approve of it and say it works fine to me. Um, Anyhow, so you don't have to like keep on looking over your shoulder and worry about, so that's what that number one means. Working software over comprehensive automation. Again, it's that idea that we're not interested in, the bureaucratic stuff of documenting everything. We're more interested in getting things done. Another common problem is customer collaboration, which means that rather than let's say, it used to be that the customer would sign a contract and then you would give them a program, a deliverable, like a couple years later, and then they would see it and then they would say, "What? This is not what I wanted," right? And you would have like this. You wouldn't show the client what you were doing until the very end. And it was all this, and it had to do with, you're worried about, well, if they don't like it, it's going to end up costing money and who's going to pay the money and all that. So the idea of, and there's another idea is that we want the customer involved with the project, right? From the very beginning, right? So like, for example, like in the military, usually when they build something, they usually have a representative like who's there on site in the factory where something's being built. So like that person right away will notice if there's an issue or not, right? Because we don't want the customer not to be involved and then only at the end being delivered something that they don't want, right? We want them to be involved. The idea is rather than being scared of the client and fighting with them, we want them to be part of the process, and therefore we're going to make them happy. Right? Our goal isn't to make money. Our goal is to make our customers happy and make money. Right? Right? Because if we make our customers happy, then they'll be happy to give us the money, right? So we want to work with them, not not against them. Okay. And also the idea of respond to change, which happens to fit in very well um, with the incremental pattern, because since we're making um, we're doing small increments, so it's easy to make a change. Like we said, like like we could throw things out or change things as we go if they don't fit into if they're going to mess up our final project goal, right? Okay, so in other words, you don't really want to redo things because that's going to be really difficult. But we could do make changes along the way, like we could throw things out. It's never good to change totally everything, as like that's never going to work. Work. It's never going to come out good. Like uh, if let's say you write a program that uses a database, and then somebody says let's instead of program using a database, let's use, something else that's, that can't be, let's say use, like it has to ask for specific data as opposed to having a data, I mean, like too radical of a change is never going to be easy to do, right? It doesn't make a difference what pattern you're using. Anytime you make a big change in the design, it's going to mess things up, right? If you planning on building an airplane and then they say, well, we really want it to be a helicopter, there's no way it's going to work well, right? So, um, okay, so this guy, by the way, Robert, Uncle Bob or Robert Martin, you see he signed, you see his name is here on the original um, Agile Manifesto. Okay, so this is what I was speaking about before. So this is a velocity chart. Okay, so the way it works is like this. It's like a sprint, by the way, is uh, um, it's a period of time. Usually a sprint is going to be um, is going to be between 2 weeks and a month, right? Usually not much. Where I work, it's a little bit longer, but it's not supposed to be that long. But it's supposed to be like 2 weeks to a month. And the idea is that if you look at the first sprint, meaning the first time when the team started the project, the light blue is what they estimated was going to get done in that first sprint. And the dark blue what was actually accomplished. So it was estimated they could do 20 units of work, whatever that is, right? They estimated that, we looked at the different, we said, okay, for our first sprint, we could do X, Y, and Z, and it's going to take, we estimated it's going to take, I'm sorry, we estimated we could do 20 units of work, but we ended up only able to do, we thought we could do X, Y, and Z, and we're only able to do X and Y, but Z we didn't have time for. So we estimated we could do 20 units of work, and we ended up doing 15. So we thought we could do more than we actually could, which is very common, right? Because we always overestimate how hard something's going to be, right? We always think, oh, I'll just do this, and this, and it'll get done, right? And then in sprint two, we got nervous and we actually underestimated it, right? We said we can only do 10, but we ended up doing 15, right? And then we overestimated it, and then finally at sprint five, we actually estimated 25 and we did 25. So after sprint five, we should be really good at estimating how much work is going to get done. So we should be able to tell in the, let's say 2 years from now, what could get done, right? We should have like confidence now, because after each sprint, we have a working program and it's a clean code also, right? So, and it's been tested. So we have the confidence to predict how long the project will take, right? Well, right at the beginning, right, we were overconfident, right? But by sprint five, we know we have a really good idea how long things are going to take. Okay? We know how people work together and stuff like that, and so we got good at it. This is another view. It's called a burn down chart. This is a different view of the same thing. So over here, um, well, we'll get to this story points in a second. But basically, we started with 360, as we started our project with 360 points of work, whatever that means. No, we assigned to each feature a certain amount of a value of how long it should take. And we started with 360 units of work that we estimated we needed. And then after the first sprint, we ended up doing, um, what's 360 minus, no, we did 90 units of work. And then by the second, we actually ended up doing a little bit less, right? So we predicted we're going like around 90 units of work per sprint. And then three, we actually went backwards. We actually, something went really wrong, and we actually had to, let's say, redo something, and we actually lost. Uh, and then after sprint three, we have a consistent line. So that's what we like. We like to have a straight line because that means that we're being consistent the amount of work that's being done each sprint. Okay? So, so over here, we were able to do in 6 sprints, we were able to do all the points, okay, of work that we needed to do. So this project was done after 6 sprints. So it averaged to like 60, right? So, right, 60, about 60 a sprint, 60 points. So even over here, we did 90, but on average, we end up doing 300, about 60 a sprint. So, yeah.
I was gonna say that where I used to work, we had our sprints for 2 weeks, like 10 business days, and each story point was equivalent to one person working for a full day. So if during a sprint you had like a really hard thing to do, you just were assigned 10 story points, and that was like, okay, you're gonna work on it the entire time.
Uh-huh.
And when we had projects, we'd have like the bank of like how many story points per, but I never actually saw the chart of like it going to like the burnout chart, do you call it? Burnout chart?
Yeah, yeah. I mean, where I work, we don't have it, but we don't have story or points. We don't do that. We just sort of like sit down and yeah, and the boss says, how long do you think this will take? And they try doing it, but I don't know.
Waste of time.
What?
It's kind of a waste of time, yeah.
And it's like no one, and it's like it's only good if someone's looking at it, but it depends where you work. Like sometimes they're very, where I work, we're sort of we do sprints, but we don't take it, like we're not rigorous. We're not like, okay, we're doing a 1 month sprint and then we're gonna do every month we're gonna, we don't do everything in there, but we do a lot of it. I mean, we do the incremental part. Yeah, well, that's interesting. Yeah, okay. Oh, so you actually worked at a place that did a 2 week sprint.
Oh, a big lot. Every day there's a scrum, agile, like the whole, yeah.
Oh, that you still work there or?
No, only during the summers and
Uh-huh.
yeah.
That's cool. Right. So every day you had to stand up. Is
Which isn't a
every
real stand-up. It's over the computer, like on Zoom. Like there,
uh,
one of our group, there's like separate groups for different teams. So like one of the groups did like 20 feet from my desk to a stand-up every day, like around someone's desk, and they talked, but we did over Zoom
uh-huh,
or Microsoft Teams.
uh-huh. Right. Uh-huh. Yes, we have a meeting once a week. That's about it. Or two meetings a week. That's about it.
Silly, like every day, like meet for 30 minutes to talk about like,
Really?
yeah.
Oh, that's a lot of time. Oh, I would hate that. I hate meetings, so twice a week is way enough for me. Okay, So, okay, wow, it's interesting. So where I work, we're not that formal, so we're just, we don't have, like I said, we just have meetings um, like twice a week for, a certain amount of time, 45 minutes, I think. Um, I'm not sure why we have two, because they're really the same thing, but whatever. But we have two meeting, I mean, it's supposed to be two different types of meeting, like different people, like some of them is for developers and some is for developers plus the, the, everybody else on the project, the testers and the business people. But it ends up being pretty much the same.
The
Yeah.
only difference is like we had the everyday Scrum stand-up thing, but then every 2 weeks we have a sprint planning meeting where like everyone on the team goes to one room and talks about the 10 sprint points that you will be doing for them
Right. But what about like reviewing what you did? When,
every day. And that's every
no,
day.
but what about the testers? They would be part of that meeting?
It was a government subcontractor, so the people that tested the code were actually kind of a different company. But it was like we had a representative from our team and a representative from Lockheed, and they was in a different facility where
Uh-huh.
it was like a big kind of bureaucratic silliness,
Uh-huh. Okay.
but the government works that way.
Uh-huh. Yeah, yeah, yeah. So yeah, but okay. So we have like more interaction between the developers and the testers. Like we have, like usually like the same day you release something, it'll be tested. It's a little bit different. Okay, but again, every company's different. Okay, so anyhow, when a project is behind, so basically, this is what we were discussing before, that when a project is behind schedule, we have basically four options. One option is to add more people, right? And actually, adding more people to a project has been shown to actually slow it down. No, I mean, once it started, adding more people, once a project has started, will actually slow down. No, it's, why is that? Why will adding more people actually slow it down? I forgot it's named after somebody who, who discovered this. Well, he proved it, whatever. Because, why? Because people who are doing the work have to teach the new people what's going on. So it's actually, so if you're running behind schedule, you say, okay, let's hire 10 consultants and we'll finish it up. It actually will slow it down because the 10 consultants don't know what's going on and they don't understand. And by the time you teach them, you're actually going to end up taking more time. So, so if you want to add people, add them before when you start, not when you're behind schedule. Um, Another thing which is, famous in the industry is you cut the quality, right? We say, okay, we don't need so much testing. We're just gonna hurry up, push out the door. But that actually is going to uh, end up taking more time because, right, what happens, let's say, when they push a car out too quickly, there's a recall and ends up costing the company more money and they ruins their reputation, right? So cutting quality is not a good idea either. So, and three, um, well, just have everybody work harder or give them more, like that happened to me once. I worked at a company. My boss said, everybody here, they're on their timesheet, so we have to see a certain amount of hours per day. I don't, he didn't say this, but he implied pretty much that I don't care whether you do it or not, but this is what it has to say in your timesheet. Yeah, because we were behind schedule, so he wanted to say that everybody was putting in extra time. So we had to put in our timesheets. But I mean, he was pretty. He didn't really care if we did it or not. He just wanted it to look like we were. Um, but in general, overtime when people work, like on Wall Street, they work these long hours. Usually, anything you do like after 5 or 6 o'clock is usually going to be full of bugs. Because you're just trying to get out. go home and you're tired, and it's usually not going to work out well, right? So it's actually working overtime, even though Wall Street gives you a lot of money for it, for working overtime is actually a bad idea because you actually are going to just get stressed out. You're just going to get bad code, right? So you're not actually getting, more stuff done. So no, four is what we said, that the only real option is just to produce less features, right? To remove what you have to do. So when you're falling behind, just do less, right? Figure out what you could sacrifice, what you could push off, and then or, maybe you only do, part of something, whatever it is, just don't try to take shortcuts in quality, just do less, have less features, right? Um, and then over here, I found this little chart over here, which I really have to make a little bit better. Um, is basically, this is like a square where you have high cost, low cost, meaning that, that on one side you have how much expensive in time it's going to take, and on the top you have the value. So there's four options. There's a high value, and so if you have things that are low value, obviously those are things that should go last, right? So, but even the high value stuff, you should always do the ones that are low cost, right? Do those right away, right? Because is a, um, if something is, maybe I could fix it right now. I'm not sure, if I could add a table. Oh, well, I'll fix it later on. So, but I did, okay, does everybody understand this is like a table? So like this is like um, I'll try to make this one color, uh, like make this a color. Okay, so the idea is that we have, that wasn't much better. You know what, let me just put this in Excel and then I'll look clear. I'm sorry, yeah. I forget how bad that looked. Uh, okay, okay, here. So, um, uh, it goes here. Okay, so I'm gonna make it bigger here. Okay, so let's say we have a, uh, let's see, that goes there. And let's make this into a table. Okay, that would be a good idea. Uh, okay, match all borders, right? So I want to go to data. Where is it? It's here it is.
Put the text together, like, you should take the text as low value, put it in column C.
Say again? Oh, here you mean?
But like, I think it's because you put the text in one cell, so I think format.
Oh,
Yeah, like just when you.
oh, this should, oh, I see.
Yeah, split it up.
Thank you. Okay, I'll go see. And then this will be, oh, this goes into, oh, right. Uh, where is this? What happened to later? Okay, later. And this will be uh, now, and this will be, I forgot what it was. It was, a low value will be never and last. Okay. Okay, so how do I get this into a grid? I'm not sure how to make this into uh okay, something like that. Okay, so the idea is that these two are gonna be okay, now let's copy this in here. Okay, so what had just happened? Okay, I should have deleted that. Uh, something went wrong. Huh? May cost. Oh, how much for AI? Okay, now I think we're okay. Okay, so if I copy this, paste it here. Okay, so basically the idea is, okay, so if you have the high value, we're gonna do first. And obviously you're gonna do the low cost first because that's what they call the low hanging fruit, right? Which means it has a high value and it's cheap, right? So that's obviously what you're always going to do first, right? So this would be what they call low hanging fruit. Know what that means? Means like things that are like, when you pick fruit, so it's hard to get to the fruit on top of the tree, but the low stuff you just put your hand and pick it up and pick it, right? So it's called low hanging fruit. Right, so that's obvious. Um, I did something wrong there. Okay. And then, and then later on, we do the high value, high cost. And then eventually, if we have time, we'll do the low value, low cost. And then probably never, right, we'll do the high cost, low value. Because we're probably never going to have time to get around to it. Probably uh, never get around. Right. Right. You ever done anybody ever took a class in time management? Right. So that's what they tell you to do, right? You put everything, let's say at the beginning of the day, you need to do, and there's like one things that you have to get done, one things that, not have to, but and then one thing is like, you're probably never gonna get to, right? So, sort of like that idea. Okay, okay, uh, okay. Oh yeah. Okay. So yeah. Uh, I just, I don't know why I put this in here, but, but it's true. As we did mention this when we did chapter two, that the best process is always going to be the process that involves no coding, right? And that is a reuse process, right? Because when you're reusing code, it's always going to be cheaper, right? Than creating something from scratch, right? So if you could, buy a airplane from a company that makes, let's say it nearly does everything you need, but it's not 100%, but it's still gonna be a lot cheaper than developing your own airplane, right? So always reusing stuff is cheaper than, nearly always, it's gonna be cheaper than developing anything new, right? So even though it might look like, wow, that's a ripoff. Why am I paying, they're charging so much money for me to do this, but it's still gonna end up being cheaper. Um, okay, and this is just examples of reuse. We look for a program, or look for a web service or It's some part, it's even when we're writing a new program, but we're always looking for stuff that's already does what we're looking for, right? Um, like especially with, um, nowadays with ChatGPT, you could have it do lots of, I mean, I personally don't advise you using it, but people at work do use it. And so rather than, work on a problem, they'll just type in ChatGPT and they'll give you what someone else already figured out somewhere else. Or it'll create something that does not true. But it'll give you an answer one way or another. So that that is the okay, so reuse is always going to be better than doing stuff from scratch, right? I don't like using ChatGPT because I think then eventually you'll forget how to program. So I personally never use it. Um, but uh, but there are people at work who, they use it. But and then I don't know that I'm not sure what the answer is about it. But so far, I don't think ChatGPT would have made would make my daily. It would just make me forget how to do things. I don't think it would make me more productive. Um, okay, so we're done for today, and we'll meet a week from today, and then I'll let you know exactly when the final is going to be. Okay, I'll just send out an email. We'll figure it out. Okay, I'm gonna try to make it a Tuesday, right? We said we'll make it a Tuesday rather than a Thursday. Okay, okay, okay. Say have a good night, and I'll see you next week.
Thank you.
Yeah, let's have some presentations. Yeah,
When do they have to be done by? When by?
end of the semester.
Ah, okay.
Yeah, but we ran out of time.